Okay, so in this example, we're just going to walk through a simple introduction of some of the tools in the Ladybug plugin for Grasshopper, which I think might be helpful for your studio work, analyzing your buildings for environmental impact, and analyzing maybe the site conditions a little further. Um, the first thing that you want to do is set yourself up with a base file. And you can just do this quickly. I'm not going to model it here with you. Really all I have is just a series of boxes, one of which I'm going to call my building, and I have that on the building layer here. The other is just some basic context. I'm keeping this model really simple because, for the purposes of demonstration, the simulations will run much faster and I won't have to lag the video too much. But of course, after you walk through this example, you should start applying it to your site model that you'll have probably already modeled by the time you see this. So I've got just a few layers over here. Oh, I also have a ground plane layer. There's just a huge surface here, which is modeled, right at the base of the boxes to an arbitrary dimension, and we'll get to that a little bit later. But the good thing is that it's helpful to have your building on a different layer and the context on its own layer. The other thing is that I'm in meters, so you'll see that I'm in my units here are in meters. If I'm not mistaken, Ladybug will work. Well, it'll assume that your model is in meters, and if it finds that it's not, it will do a conversion for you. So it's best to convert your model to meters before you try these simulations and have it prepared so that when you're trying to visualize things, everything's at the right scale. Okay, let's get into it. All right, so I'm going to open up Grasshopper here, and if the installation went properly, if you followed the directions and everything went well, you should see the little Ladybug tab here, and it's got all these components, colorful ones here. I don't know if this will work for the Mac, so let me know how that goes. Okay, so the first thing we got to do is see if Ladybug is working. So let's and you have to grab this component first before you can do anything else using this plugin. So you go over to this first tab here, grab that first component. It's called the Ladybug component, and drop it in. And there may be a delay, and then what we want to do is it's good to just grab a little panel, and what we should be seeing is this little message saying that the Ladybug's flying and should say hello to you with your username. And that would give you an indication, first of all, that the plugin is active and working just fine, installed properly, and now all the other tools that are associated with this plugin will now work. Okay. The next thing we need to do is point our plugin to some data. So we're going to go back to the Ladybug plugin, and over here we can just use this third one down here, the download EPW weather file. Okay, and this is going to take us to a website to download some data that we can use for these simulations. And what it's going to need is it's going to need a Boolean toggle, and it's going to tell me set download to true. So I'm just going to go over to parameters, input, and Boolean toggle. And once I hit true on this, it's going to pull up my browser, right? And you'll see the same. Okay, and it's going to take you to this website here, this EPW map, and you can zoom in on an area that's near us. So this area here in Buffalo is going to give us the weather data that we're looking for. So go ahead and click that, and then it's going to ask you to download from the Department of Energy, or you can link it to clipboard. There's two different ways to do this. We're going to use the download option. So go ahead and download from DOE. And that's going to save a zip file. Okay, so hopefully that's somewhere. So let's show that in folder. And you can see that it's a zip file. So what I'm going to do is I'm going to right click on that, and I'm going to extract those files. Okay, and that'll bring me down to the folder. And it's inside of that zip file. There's three different files. All we need is the EPW file for Ladybug. You can delete the other two or keep them. But all I need is this EPW, and I'm just going to have to point my Grasshopper toward this file. So I'm going to put this on the desktop to make it a little easier to find in the next step. So I'll just, yeah, I can replace that. I already have one there, as you can see. So I'm just going to put it there and carry on. All right, so we've downloaded that, and now we'll head back into the Ladybug tab here, and we're going to find the open EPW file here. So the open, it's going to be the second one here, the open EPW weather. You can ignore the one with the stat. And here again, it's going to tell us that we need a Boolean toggle to tell it when to run. All right, so let's go grab one of these again. And then when we hit true, it's going to ask us where that file is. I know mine is on my desktop because I just grabbed it, or I just put it there. And so let's select that and click open. So now we've got a data file that we can start drawing information from so that our simulations are accurate, at least to that information. So depending on where your site is, if it's in Buffalo or if it's in Pittsburgh, wherever it is, you would find the proper, first of all, the proper EPW file, open that file, and then the data that comes out of it, out of this output here, will be used for the rest of the simulations. Well, let's say for the other components of Ladybug that crunch the data to give you an output, sometimes simulation, sometimes data visualization. Okay. There is one more way to do this, and I wanted to show you it because some of you may be collaborating on this file, and the thing to remember is that if you are going to share this file, you're going to need to also share the EPW file that we downloaded so that this can run. It won't save this directly inside. So one thing you can do instead, if you know that the person you're collaborating with is going to be connected to the internet, you could find another way, which is to grab the open EPW and stat weather file component, the one that we ignored last time. And this time it's going to ask you for the weather URL. And this is kind of nice. So what we can do in this case is we can head back to this map. We can right click on the download DOE and we can copy that link address. All right. And then we can grab a panel and we can paste it in there and we can pop it in there. So what's nice about this version is again that if you're going to be sharing this file, what it'll do is as soon as you open it up, it'll start downloading this file, assuming of course the computer is linked up to the web. And that way you'll get your information, all of your data that's required to run the rest of the work that you've done without having to download it themselves. So this is kind of a nicer way to collaborate. I'm just going to leave this over here just as an example, and I'll just turn that off. So because we'll just use this one for this example here. Okay. So the first thing I want to show you, there's going to be multiple things that we'll try out here. And again, these are really simple introductions, but the first thing I want to show you is the how you would calculate the kind of solar radiance, the solar radiation on your building in this context over a certain kind of duration of time. And this will give you a sense for which surfaces on the exterior of your building will receive the most sun and which will receive the least amount of sun. So let's go back into Ladybug here. We'll start setting this up. We're going to go to this tab 2, Visualize Weather Data, and we'll grab the Generative Cumulative Sky Matrix component here. Okay. And it's going to ask you for the EPW. The good thing about this plugin is that's pretty descriptive in terms of what information it's looking for. And I have very little experience with this, but I have found it pretty helpful in that way. And the other thing is that these components, because they're pretty heavy, meaning that they do calculate quite a bit of information for you, there's always there's very typically a Boolean toggle on them, allowing you to run or turn them off. And I highly recommend being very conscious of this so that, especially before you save the file for the day and go home, turn all of them off because when you reopen it, it's not going to try to calculate everything all at once. And it could mean that if you do that, it could mean that either the file takes a very long time to open, or it could mean that it crashes your computer every time you try to open it, which would make it useless. So this is something you should be pretty conscious of here. And go ahead and click True. And this may take a few seconds. And you might get a little beach ball here or a wheel. And that's pretty common. So you want to just let it do its thing and think. And sometimes Grasshopper disappears after it's crunched a bunch of information. Just re-click on the window and it'll come back. Let's see what we got here. Should be okay. Yep. All right. So it now has, yeah. And because I already had you're probably going to say something else. I already had a matrix file for this particular location set on my system, and it won't recalculate things, but we should be okay. Cool. All right, so because we're looking to do radiation analysis, let's do that. So we'll head for Ladybug. Let's see if we can find a component that says that. So let's go to number 3 here. And the first one in the list here is Ladybug radiation analysis. Let's drop that in. And it's this big one here. And it's always good to have a look first at what it is it needs in order to produce the result for you. So one of the things to pay attention to is, in this case, it's looking for a selected sky matrix. We have a cumulative sky matrix, so what we need to do is go from this component to another one to get us our selected matrix. The other thing is we're going to need to set a grid size for the mesh output. This will be a resolution of the gradient. The distance from base is something that's kind of a default standard. I can show you that in a second. It's looking for the geometry, and this is, in this case, will be your building, and then the context is going to be the rest of the objects on screen. So there's going to be the buildings that surround the massing that you're designing here. The other thing is going to ask for a north arrow. By default, it's going to be the positive y vector, but that might not be true for your model. So I'll show you a quick way to just set a custom north. Okay, so by default it's in the positive y, but if we had a model where north was, let's just set it up between 2 points. And let's say north was in that general direction, right? Imagine that as an arrow. So I could set a 2-point vector between those 2 points, which will match, your the way you've modeled it in Rhino. However that's sitting, it doesn't really matter. You can set a north however you need to in the screen here. So we'll go over to vector tab here, grab a 2-point vector. All right, and we're just going to bring a couple of points in. And you should be kind of familiar with this by now. So the start point, remember that the start point though has got to be at the bottom of the arrow, and the end point is going to be at the front of the arrow, because this is going to set a direction in space. So this is not arbitrary. All right. So that's going to set our north, and if we want to visualize that arrow to make sure we got it good, we can go over to display. This is our first point, and then the vector here, and there's your north arrow being shown on screen. And if you internalize these points, you don't have to worry about them not saving when you reopen the file. You can delete these points here, and now you've got a little north arrow that's being shown as a reference. All right. Okay, so we can put this vector now into north. And let's start bringing in our geometry. So we'll go to parameters in brep. All right, so we're going to bring in a couple breps. I'm going to make 2 of these. I'm going to rename one of them, right click, and just kind of rename it to, I'll just call it geometry. Kind of follow the naming conventions here, and context, so that I remember which is which. For the context, I'll right click, set multiple, and just grab the surrounding buildings. I can pop that in. And for the geometry, of course, we'll just set our design building. our project, if you will. Put those over here. Okay, and here's where it might be time to turn these layers off. So what I'm going to do is make a new layer. I always have a sandbox layer, one that I can leave on while I have other things off. All right, good enough. And you can make custom colors on this, and we'll probably get back to that in a little while. The other thing I'm going to need before I forget, similar to using things like Kangaroo, is to always make sure you've got a Boolean toggle on the run input. And right now it's set to false, which is good. It won't run anything. And if you've got a multi-core processor on your computer, you can also plug that into parallel, which will mean that it'll run the cores in parallel with one another to speed up it'll speed up the simulation quite a bit. So again, if you're running I think most processors these days have multiple cores, and that's a good option to select if that's the case for you. If you don't know, you can leave it off and or turn it on to see what happens. Don't think it'll hurt anything to try. Okay, and the last couple more things. So grid size, distance from base. So I'm just going to put in. Now this is going to depend on the scale of your stuff here, right? So I'm going to go small because I know that it works, but you might want to go large on this. Actually, when I've done this before, I've used 5 instead of 0.5 in my grid size. So matter of fact, let's do that here. And I'll come back to showing you why you'd want to change it. So let's make that large just by default, and then we'll just bring down the distance from base to something small, just so that it's above the ground plane a little bit. I don't know exactly why that's necessary. This just comes from a little bit of experience of tinkering around with this software. And we can leave that one alone, but this one will probably update and change. Okay, so the last looks like the last thing we need is just this selected sky matrix here. So let's do that. Give myself a little bit of breathing room here. Go back to Ladybug and see where this thing is here. Probably going to be in the visualize number 2, visualize weather data. Yeah, it's this one here, Ladybug select sky matrix. Got the little downward facing arrow. And it's nice. So now you just connect dots that are leading into one another. So cumulative sky to cumulative sky. Analysis period is one that we'll need to set. Okay, so we'll need one more component for that. And I believe that's going to be over in our, let's see here. Right, so number 1, tab 1, Ladybug analysis period is the first component there. And this is going to allow you to set a start time and an end time, different times of the year. So let's set up a couple of sliders. The first one is going to be the month slider. So just double click on the gray area here and just type in 1 less than 12, and that'll set you up with a slider between 1 and 12. All right, so that's a nice quick way of doing that. And that's 12 months of the year. Let's make another one, which will be between 1 and 31 for the days. Okay, so that's the day. And we'll do one more for the hours, so that'll be 124. And there you go, 24 hours. And we can copy and paste those 3 and put them into the next set of 3. And it's going to say red because this is all the same, which means there isn't any duration implied. So if you just change one of the sliders, immediately it'll turn gray. Yeah, so what this is January 1st at 1 o'clock in the morning. All right, so if we wanted to change this, to a different time, we can do that. For now, it doesn't really matter too much. I'm just going to do something like this, which will basically give me the full year, I think. Yeah. Yeah. And we can plug this into analysis period. Okay. Okay, and then we can go ahead and just plug that right into our select sky matrix. All right, and when all that's set up, go ahead and make that true. And on my screen, it's going to happen quite quickly again, because this is a very simple simulation. There's only a few boxy objects. There's not much complexity here, and it's not really calculating much. But here's our analysis. So actually, I'm not sure why it says 1961. I guess that's based on. I'm not sure if we can change that. Yeah, I don't know. But anyway, the January 1st, 1 o'clock through December 31st at midnight is going to tell us how much radiation that this building here gets in this particular site with that facing north, if that's facing north. All right, so let's clean this up a little bit before we keep going. I'm going to turn this back down to here so that we get a much more higher resolution mesh. And when I do that, I might have to wait a second. Okay, so there we go. And now I have a little bit more resolution on that mesh. The other thing is I've got this overlapping preview. That's going to start to become annoying, so I'm going to turn that off. And now that mesh is shown as is. Now, by the way, if you're not seeing these mesh edges like I am, you can just go to display and turn them on. It's up to you whether or not you like them on or off. You know, sometimes actually seeing it this way is kind of nice. It's more of a, gradient condition. I'm going to leave them on for this. All right. And you'll notice something that let's go ahead and turn on our context layer for a second. And let's say I move this building over. I should get a new result. And it may have to calculate, so I'm going to let that calculate. And now you can see that a portion of the building over here is now in shade for a good portion of the year because the context has shifted a little bit. So that's a good way to get a kind of up-to-date, quick analysis over, positioning your massing relative to buildings, or, thinking a little bit about whether or not the context changes in the future, things like that. I'm going to turn off that preview. Maybe leave this on. The other thing it does is it gives us this key, this kind of legend here by default, and I'm going to talk a little bit later about how we can customize this. But in any case, this is giving us our first result. Okay. And let's go ahead and change. Maybe we'll just also change the duration. And I'm going to turn this to false for a second because I don't want to update that. I don't want this to be calculating as I make changes here. But let's say I just wanted to go with, I don't know, let's say June. I think that's the solstice. We'll say noon. Well, no. 8 a.m. to, so let's calculate one day instead of the entire year, for example. If we wanted to just look at the time of the year when the sun is at its highest. Let's say from 8 a.m. to 4 p.m. Okay, well, no. More like 6 p.m. maybe makes more sense. And now we could update this and turn it on, let it calculate. And now we're getting just a picture from just one day, June 21st, 8 to 6, and this is the projected or simulated solar radiation of all the different surfaces of this building. As you can see, a much cooler side. Just because a lot of that sunlight's going to be blocked by this larger building. Of course, the top of the building is always probably the most exposed, and then by the time we come around. Yeah, so this is the side here. It looks like that's going to see your most solar heat gain, and this might give you some indication for where you might want to put the majority of your sun shading or make the building more opaque, things like that. And that's more up to your studio faculty to help you analyze and walk through the different options you have when it comes to incorporating this analysis somehow meaningfully into your design project. All right, and while we're on the topic of solar radiation, let's look at the radiation rows. And this could be a nice diagram if this is going to be something you're going to be looking at in your project. We can go to the visualize weather data, go over here to Ladybug radiation rows, and it's another one of these monster components. Just put it over here to stay organized. Grab a new Boolean toggle. We'll set that to true when we're ready. We have to update our north position, all right, because these components will have to be matched. So I'm going to put this through a vector component that I can use to copy around and make that my north. The selected sky matrix is going to be the same one that we used over here, okay? The context will be the B reps that we used for context, and I think that's enough. I don't know that you have to put the building in on this. Where are those things? Oh, they're there. Let's put these over here so they're a little more, oops, so they're a little more visible. Cool. All right, context. So let's drop those B reps in there, and you can play around with these when you have some more time to figure out, you know, the different kind of visualization options you have. We can go ahead and click true. Let that calculate. All right. So now if I zoom out a bit, yeah, it's kind of large, but, and I think you can probably set the scale. Let's see here. Default is for 1. Let's see what happens if I make it a little smaller. Maybe it'll be, yeah, okay, that's nice. That's a much better diagram, and it's going to give us all this nice information for different, let's see here. So this is direct radiation between those hours. It'll tell us our diffuse radiation in that time period, and this is the combination of the two, right? Again, so and this should match. I mean, it's very likely to match, you know, the radiation results that we see on the surfaces of our building here. And again, this is going to give you some sense for where you might want to minimize glazing, you know, on this part of the building, just due to how much solar radiation is occurring, at least at that time. Now again, we could change the duration and see how this updates. All right, so let's turn these off. Let's change our duration to be, again, throughout the year. Crank these all over. Give us our full range. We'll turn these back on. And the results seem to vary a bit, actually. All right, so now, which does make some sense, doesn't it? When the sun, before when we had it at the summer solstice, you know, the sun is pretty high in the sky. The angle, at least, is pretty high in the sky. So in the early part of the day, this part of the building is going to get a lot of sun. But throughout the year in Buffalo, you know, the southeast, south actually in this case, direct south, you know, of course, should be giving us, just based on our latitude, should be giving us quite a bit of solar radiation throughout the year. Okay. Yeah. And the other thing I guess I should point out is that the line work coming out of here is, I believe, stuff you can bring out, and yeah, so these are actually, so this is the base curve, so let's take a look. So you can actually bake this stuff out. That went red. Let's see, mesh to curve. Okay, that's weird. All right, I guess we got a bunch of meshes in here. Let's take a look at the data. Oh, there is one mesh in there, I guess. A bunch of meshes. Okay, interesting. Yeah. Let's just output this geometry here. Where is it? There we go. So there's a bunch of curves that you can bake onto a different layer, and you'll bring it into Rhino that you can then go ahead and, you know, customize using your own line weights, your own text sizes, stuff like that. The radiation arrows mesh, that's also something you can bring in and create your own custom drawings with. Okay. Yeah, we'll talk a little bit about that again a little bit later too as well. I'll get back to that. I'm seeing this overlapping here because I still have that on, so I can turn that off. You know. All right, so if we're satisfied that we've got this working, I'm going to turn them both off, and I'm also going to shut these previews down. Well, yeah, if they're off, they're off. But you can also shut the previews down to make sure. Okay, let's. I'm going to turn my geometry back on for a second here and get started on something else. Okay, the next one I want to show you is the view rows, and this can be pretty helpful if you're trying to analyze the view out from the building into its context. So it's going to give you a sense for what you can see and what you can't based on you know, the surrounding buildings. Okay, so the first thing we're going to do here, just to set this up, we'll go over to Ladybug and environmental analysis here. It should be in there. Yep. You can see the Ladybug view rows component, so let's grab that. And I'm going to start setting them all up over here. In this case, we've got something called geometry. In this case, what you want to do is you want to bring it all in, not just the contextual buildings, but the building you're designing as well. So for this, what we'll do, I guess, is just merge them together. So I'm going to go to sets, and I'm going to take both of these B reps here, you know, and I could turn that that preview off, but I'm going to take both of these, make sure they're all in there, and that'll be the context for this one. Okay. Now the other thing, now we're going to have to set a plane for this one, and you're going to want to leave it at the XY plane. All right, so let's go to vector, grab an XY plane. By default, it's going to put it at origin, but your building may or may not be modeled directly at origin. So what you're going to do is put a point in Rhino at the center of your building, or wherever you want your view rows to be, basically your viewpoint to be set to. In this case, it coincides with 0, 0, 0, so I'm just going to move this to the center of that building. Okay, and then I'm going to move it up a little bit to demonstrate that. All right, and I'm going to set that point into Grasshopper, and I'm going to internalize that data so that I can move it around as necessary. All right, and I can go ahead and delete that point later. Cool. All right, now I'm going to put a plane there, at that point, and plug that in. And the last thing we need to do is set a radius around this thing, I believe. Yeah, so we need to set a radius, and that's going to depend. We're going to have to make that a variable. It's going to have to be something kind of large because you want it to be larger than the radius that surrounds your building. It depends on how much context you have modeled here. So I'm just going to say 50 meters and see where that takes us. That's pretty good. Okay. Yeah, and I can tell now that I've actually made a bit of a mistake. I got a couple things confused. So you can delete that merge component. Actually, you really only do want to give this the context if you're going to be looking through from the building out. You really just want to give it the context buildings and not your building itself. And you can see now when I've updated that, I'm getting a much better idea for what I can see from this point in my building outward, which makes total sense. It kind of makes a little cut of the surface, around where these big objects get in the way. And I can move that around a bit. I can move this in space a bit, so I could be at the edge of the building. Let's say I'm looking out the window on that part of the elevation, and that's going to change my viewing angle. As I walk to the other side of the building here, I might see a little bit more around it, and so on. So this is pretty nice. I think it's pretty helpful to analyze, what it is you'd be actually seeing at different levels of your building, especially if you've got more context modeled than I do here. And what's cool too about this is that it does output this as both a surface, which you could hatch, or color in different ways, even just in Grasshopper for a screenshot view. You could also output them as curves that you could, there you go, that you can then, line weight and add hatching to make nice drawings as an output to this. So again, these components here are going to give you this visual representation on screen, but they're also going to give you some geometry that you can work with in a drawing. Okay, so that's something that I think is going to make your work more unique if you can extract this information out and create drawings that are of your own authorship and your own kind of graphic style using this kind of data visualization that comes out of this kind of this plugin and this way of working. Okay, another one that I think has been in demand this semester from you guys for this initial analysis phase is some basic idea, I guess, for the prevailing winds, direction of winds. So I'm going to turn this stuff off. You can just leave it there. And let's take a look back in Ladybug tools here and see what we got. Let's, visualize weather data. We have a wind rows option here that we can use. So let's grab this. And let's see what it needs. One of the things that it's going to need is, of course, the hourly wind direction and wind speed. So you got to give it data for that. And what we need to do is find out that data from our EPW file from the Department of Energy. So we'll go over to Ladybug here, and we're going to import that EPW information directly into our Grasshopper world here so we can extract some of that info. So I'm going to grab this. Again, it's a monster of a file, our component, and then I'm going to plug in our EPW file into it like this. I'm going to bring this down. This will also be helpful for the next step, not only for wind, but also for a sun path diagram. Remember that our north needs to be updated, so let's update north. And that's this vector over here. I'm going to just create another vector so I can bring it down to this other side, like that. And let's see if we got what we need. We have wind direction, good. So let's pull that into the first one there. And we've got wind speed, hourly wind speed, done. All right. The other thing is going to be scale. We can change that later. Boolean toggle, run it when ready. And I guess we could run this. So let's run this now. And let your computer think for a second. Could take a second. Okay. Yeah, so here's a wind rose of the different kind of intensities of wind coming from different directions, different times of the year. Again, this is going to give us, it looks like the overall year, January 1st, December 31st. If you wanted to set a analysis period, you can do that using the same component that we used before, this one here. So let's say we wanted to, if you wanted to just copy and paste this and make customize it a little bit, make changes, we can do that down here. First thing I want to do though is change the scale. This thing's kind of crazy. So what did we have our other one set to here? I think we had it set to just a 0.25 slider. That's a default slider. So let's change the scale of this as well. It's too big. Let that calculate. Good. Yeah, that's much better. Very nice. And, again, if we wanted to, let's say, just try, let's see, when's it pretty nasty? I guess February. No, what, December? December's pretty windy, right? Let's just say, like, yeah, December 12th from, like, 6 in the morning to, let's just say March, just about when spring hits. Yeah, and we'll say the same time. Doesn't really matter the hour in this case. Now we can change our duration, our analysis period, and update that data. And it looks like it's still, okay, that's very small. Oh, interesting. The wind rose, turns out, is relative to the data that comes out. So it scales itself to the intensity of the wind that comes through. So you have to scale that one up a little bit to see it and adjust accordingly, like I just did there. So that's something to pay attention to. And now, at least for one day of the year, we can kind of get a sense for where all the wind's coming from. And it looks like it's common for the wind to come from the northwest. Within that duration, sorry, not one day, but within that set of months, 3 or 4 month time period. All right. And I'm going to turn this off. I'm going to disconnect this, actually go back to where we were before. And then I'll change that scale to something a bit smaller, because it's probably more useful for you to analyze the overall year as opposed to just a small chunk of the year. Okay. All right, so let's keep going. Turn that one off. Okay, from here, let's create a sun path. This is also something that I think you've been asked to start analyzing on the site. So let's go to Ladybug and let's see if we can find it. Yeah, visualize weather data, Ladybug sun path. All right, and we've got just about all the information we need over here. I'm going to put it next to the wind rose. Kind of keep these things organized. North we're going to need, and we have that vector right there, nice and conveniently. Location also comes directly out of this import. So you can see that here. So location's the third one down. We're going to connect to the second one up there. Alrighty. And I'm going to copy and I'm going to do this. bring this over here. Whoop. And I'm just going to copy and paste 3 of these just to get started. And we'll update this once we get it working. And we're going to plug these into the hour. Now this is a little bit funny. It's not organized the same way. So this is month, day to hour. This one is hour, day to month. So pay attention to that because your sliders are set accordingly. So we just have to kind of reverse them. Okay. And I think it's nighttime. If it goes orange, it'll tell you that it's nighttime or that it's dark, so there won't be any sun. And you could just adjust these sliders so that goes back to gray. You do need to then let's see if our scale is correct here. Yeah, this is not bad. It's a little bit large. And you know, again, if you're modeling in the wrong units, let's say you're in, you know, inches or something, this thing won't even be visible a lot of times. It's going to be huge. It looks like you can, and you can probably just change all the sun path scales to turn them down a little bit, and you know, make them so that you can create a diagram that's a little bit more, I guess, scaled more appropriately to our context here. But I'll leave it large, you know, in this case. And you can see that I've got a little sun, and if I move this around hours of the day, that little sun's going to dance around the path, and the different days of the year, or in this case of the month. So you don't get a huge change, of course, there, but you do get a bigger change as you move through the year. And that's going to go around this little loop. Okay. Let's look at a longer duration. So let's do something like this again. And because you know, I don't want to go too crazy here, this will give you all the little suns and all their directions at the duration that you tell it. So in this case, I'm just going to give it the summer solstice, the entire day, 24-hour time period, and I'm going to override these by plugging in this analysis period. All right, and then there's all of our little suns coming through here. Pretty cool. And now we have sun vectors that we can visualize here. All right, so let's go to display. Oops. Yep, and these are our vectors. We're going to need to give this an amplitude actually. So let's see. The sun positions is going to be down below here. That's the little point at the center. So that's our anchor. And we need to give this an amplitude. So let's double click in there, find our amplitude component. The vector, we're going to give some more strength to, so we can actually see them. And I'm just going to put a panel into this. Maybe 100 will work. There you go. So that'll give you, you know, again, a little bit of a visual on your sun angles. Centered to the origin of Rhino in this case. But you can change that center point if you need to. Okay, so again, if your building is off, you know, off somewhere else, find that center point. That same center point that we used for the view rows can be used in here, and you can move your sun path diagram to be centered around your building pretty quickly just with this center point. Again, you can change the scale, projection, all the other inputs here. You go ahead and play with that on your own. Just wanted to give you a sense for how to start using this. The other thing is, yeah, you do have the sun positions, path centers, and all of that comes out for you. Path curves could be very useful for drawings, especially if you want to start customizing it into nice line weight and so on. So please do pay attention to the outputs if you're going to use this. And again, don't rely on the kind of standard graphic, you know, styles that you've seen. I think you should, you know, work the graphic styles into your kind of graphic theme that you're playing out in your boards, and you know, make it a little bit more your own. Okay, so there's our sun path. Okay, and let's build on this. We're going to do two last things. One being the sunlight hours analysis. So how many hours of sun within a duration do we get onto our building? So this will be related to the radiation analysis, and you can also relate this to the sun path diagram if you'd like. The other thing we're going to do is some shadow analysis, and I'll probably end there because the shadow analysis is I think another one, or the shade analysis is another one that I think is also required of your studio analysis project. I'm just going to turn this one off so I don't, and I'll turn these off. Get back to that later if we want to see them. But what's nice is that this gives us a sun vectors output, which we will need for the next step. Okay, so these kind of build on one another if you're not already kind of catching on to the theme here. One builds on the next, and you can kind of work in that way. I'm going to go over to Lunchbox again, go to environmental analysis, and you'll see the ladybug sunlight hours analysis. Okay, and there's some common things here. A lot of this stuff we already have set. We can do some copy and paste, or we can reuse some components. Okay, so let's see. Let's go up, put it over here, I guess. For now, let's plug in our north vector. The geometry is our building. Okay, so what I'm going to do in this case, because I'm going to need these sun vectors, I'm going to put it over here, and then I'm just going to make a copy paste of these components here, geometry and context, and then I'm also going to do a copy paste of the grid size and distance from base, because I believe we need those as well. So I'm just going to bring this stuff over like that, and we can turn off the previews because we already have one on. Alright, so let's plug in geometry, context, distance from base, and grid size. Alright, and then we can clean this up for a second here. Good. Okay, cool. Alright, and the last thing we're going to need, I guess, is, well, two things. Let's put on that Boolean toggle so we can always turn it off, and that goes into run it parallel if you're running 2 cores or more. And the sun vectors is our last step here. All right, and that's coming out of this component that we just used for the sun path. So we have now our sun vectors that we could plug into this. All right, let's go ahead and run that. Let that run. Okay, that one's pretty quick. Very good. And yeah, cool. And now I want to go back and turn off this preview so that we don't get overlaps. And within this is a yearly duration, I believe. Let's see here. Sorry, no, I think it's the sun vectors are going to be read from this last component, and this is the duration that we set. So this is the daylight hours on this duration that we have here. So if you wanted this to be the full year, you can make the change here, and you can update your sun vectors. Okay, so this is a multi-part thing, which means you want to be kind of careful with playing around with sliders when this is still being asked to calculate. Okay, so we should turn that off. We could, what I'll do to be safe here, I will disable this one. I'll turn this to, all to ones. Let's make it for the full year. We'll enable this, and we'll wait for a second. And we'll cross our fingers that we won't crash. Okay. We did not crash, good. And I'm going to go ahead and save because I definitely don't want to crash here. And I'm going to turn that back on. See what our daylight hours look like for the year. And this could take a few seconds, especially on your laptop. This could take a little while longer than what you're going to see on my screen. Okay, so that took maybe about a minute. I did pause there, and this will give us, the amount of daylight hours that are hitting our as an average throughout the year, and it'll output those hours for you as numerical information that you can also use in your analysis. Okay, so careful with this one. It did take my computer a while, and it's a pretty strong computer, so if you're running this on your laptop, yeah, you may not want to do that step that I just did there, and I will make a note of this on the UB Learns. In any case, there's our daylighting, and what I'm going to do is pause for a second and just update this so that it's only duration for a day again, so I can always refer back to it. So just 1 second, and we're back. Okay, so there's just, there you go. Yeah, pretty nice. And, these components also have a lot of information, so if you hover over them, it'll tell you, you know, what it is, which is pretty nice. So it calculates the number of hours of direct sunlight. Can be used to evaluate the number of hours of sunlight received by vegetation in a park, or the hours where direct sunlight might make certain outdoor space uncomfortable or comfortable. Also used for coarsely gridded shadow studies. And it's also foreshadowing what we're going to do next, which is the shadow study. Okay. It's also saying a little bit about honeybee stuff. We're not going to get into honeybee in this class. If this is something that you're going to start doing in your studios in terms of analyzing interiors, you know, daylighting effects, different levels of comfort in the interior of the building, you're going to need to install some other add-ons to your computer so that you can get the proper information for that. Ladybug doesn't require it, but honeybee does. So it's a little bit more of an expanded, you know, an expanded topic that I don't think is necessary to get into unless, you know, some of you in your studio work is really going to start engaging with that. Maybe we can, you know, we can look for some resources for you. Okay, so I'm going to turn this one off, and I guess we can turn that geometry real quick. And now I'm going to walk through a simple way of just analyzing shadows, which is also quite helpful. I know that some of you have already started doing this using Diva and stuff, which is great. Here's another version of that if you want to use this software instead. Okay, so let's go to Ladybug, and in this last component over here, this number 7, you're going to find the shadow study. All right, and here's where you're going to need a ground plane. So let's turn on that ground plane, and let's bring it in. So let's grab a surface parameter. You know what? Yeah, I think that should be okay, but I'll bring it in as a B-rep anyway, and just select it. Okay, and I can turn that ground plane off for now. Don't need to see it. Cool. And I'm going to label this ground so I don't forget. All right. Now here's the one where we're going to need to bring all this stuff together, and this is where I got confused earlier. We're going to bring all this together and merge it all into one input. This needs all geometry, okay? So all the stuff that you want to test shadows hitting one another, so that all these objects in the real world are going to cast shadows, and they all need to be input into this same thing here. So let's go to Set, Tree, Merge, and we'll just start putting all the stuff in there. Context, geometry, and ground. All right. And we'll put that in. Okay, now for this one, it's going to ask you again for a sun vector. And we do have a sun vector over here, but let's see what we got. We've got 15 sun vectors. That's going to be a bit heavy for this initial analysis, okay? So what I'm actually going to do is head back while this is off. I'm going to head back in over here and make this, I'm going to disconnect this analysis period. Okay. Now all I'm getting is a sun vector. Let's take a look. There's my sun vector. Okay. And here's my sun path if I want to see that. There's the sun path. The sun vector that I've got selected is based on these sliders. Maybe we can leave that alone for now. It's a bit high in the sky, but let's go with it. We'll turn it down a little bit. Maybe we'll go a little lower in the sky. Get some more extreme shadows here, just for the sake of argument. So we're in November. Cool. All right, so that's our sun vector, and then let's go ahead and plug that in here. So there's our vector. And we'll let that thing run. And again, this is going to take a second or two. Okay, so that happened pretty quick on my machine. Let's take a look what we got out. A bunch of meshes and meshes. So there's shade, which is the parts of the individual objects that are not in the sun. So these are the self-shaded parts of the B-rep. Okay, the shadows should be self-explanatory, but these are the cast shadows by the B-reps on other B-reps. Okay, so that means buildings casting shadows on the ground plane and buildings casting shadows on each other. All right, so let's take a look at visualizing this stuff, and then I'll show you a quick way that you could output that for vector drawings. First, let's take a look at it, and we can turn this preview on. And yeah, it's kind of nice. I mean, it's going to look a little choppy and stuff, and this is because it's a mesh output. Let's take a look at the difference between the shade and shadow. Okay, so let's turn that back off again. I'm going to go up to grab a custom previewer and a color swatch, which I think by now you should be somewhat used to. Make that dark color, maybe like close to black there. So there's our shadow play, which is pretty nice. And what I'm going to do is turn on the building here. There we go. Let's zoom around, play around a little. It's pretty nice. Another thing I actually like to do for this one, you know, we're getting this kind of overlapping preview kind of thing going on here, so it's not a bad idea to turn these layers off, I guess, in Rhino. And then we'll go to surface, we'll grab this B-rep edges component, and let's just take a look at, so we'll take a look at our B-reps just as edges, almost like a wireframe, which is kind of nice. You can change the color of that if you like. We just flatten all this and maybe make it white or something so that it's an opposite contrast in color to the shadows themselves, which is kind of nice. Yeah, now we can really take a look at, you know, how the shadows are being cast on the buildings and on the ground. Now, you know, again, if you make a shift to the angle of the sun, this should update. So I'm going to right-click or double-click on this and make this June and hit OK. And now we're updating our sun angles here. So it's much higher in the sky, and the building's going to catch a lot more sun, and they're going to cast shadow a lot less on one another. Okay. So this, in conjunction with the other analyses, is going to give you a good idea for, you know, how much solar radiation is really going to be happening here, which in this case in June it's going to be quite a bit. Try January. Pretty low, much longer shadows. All right, so let's take a look at this stuff as output. I'm going to go back to November. I kind of like the way that looked. Well, try September actually. Maybe we'll get them a little shorter. Yeah, that's good. I'm going to turn off this there. Okay. So again, these are kind of mesh outputs, and they're kind of, in a way, a bit sloppy, but we can work with it. So since we're working with meshes, we'll go to the Mesh tab. We'll head over to Utilities, and first of all, let's see if we can join these together to clean it up a little so that there's less fragments. And that's going to join the meshes together that are touching. And then what we can do is, for the sake of a little bit of time as we test stuff out, I'm going to just grab the okay, that came out a little cleaner than I thought, which is good. So let's just go over to mesh, and we'll just extract the mesh edges and see how those come out when we do a little bake. Okay, and I'm going to run these through a join component. Join curves to see what kind of outer curves. See, this is going to give us the outer edges, which is pretty nice out of E1. So there's some of our outer shadows, the outer profile of the shadows. So that could be used in a line drawing. You can bake these on a certain layer, let's have a look at that actually. So I'm going to make a new layer. Call it shadow edge or something. Bake that in. Minimize this. Actually, before I do that, I'm going to turn off, just hit the little green cylinder up there, turn all that stuff off. Cool. And see what I got. Yeah, so there's one. There's another that's kind of all connected, so I want to modify this a little bit. All right, so let's look at this one first. So we can add a hatch to this if we want. Try something like that. This one will need a little modification, so we could just take this, we can explode that. And let me turn on my context here, see what we're really dealing with. All right. So it looks like what I want to do is show, oops. Yeah, I kind of want this, this, this. Start selecting our edges that we want to be continuous so we can make a continuous hatch. And I want to go back down in this direction. All right, join all that together. Give it a hatch. If I can spell, there we go. Something's wrong here. Yep, I got one missing, so join all that together. Now we can make our hatch, I believe. I'm not sure what's going on here. Hatch. Combine regions, yes. Output. Okay, there we go. Needed a little bit of work, but we got it to go. Turn on our context again. That's starting to look kind of nice. All right, so now we're going to want this one to kind of, this one is kind of tricky. It comes up onto our building, onto one of the buildings here. Yep. So we're going to want to draw in some new lines. Let's see. Yeah, I'm going to go to my sandbox. Well, yeah, I guess I can figure this out. So I'm just going to go ahead and do this. And then make a new, I'm going to explode that. You guys could probably just skip ahead and see the result of this, but I'll just keep recording. All right, there we go. Join. There's another one. And then I want to bring it up on the building as well, so I'm going to need a corner to that. So let's see, context. Yeah, there's my corner. Simple enough. Just need a new line. From there down to that corner point. Cool. Getting close. Do this. Boom, boom. And here I need to make an explosion. And just redo that. So it's a little bit of post-processing, you know, and that's always going to be the case. Unless you do a different kind of screenshot, you know, overlay or something. If you're going to do vector work, you're going to need to do a little bit of post-processing here, but nothing too crazy. All right, all set. And there's one more over here, I guess, if I'm going to be. Okay. And there's a nice little hatch drawing of shadows. And we can always make adjustments to this. If we want to change the pattern scale, we can do that. Okay, 2. Pretty cool. I actually kind of like these hatched shadows. You know, I think that looks pretty nice. Personally. There you go. So this will be a nice, you know, this will probably print really well. You can change your line weights, make it really, you know, pretty nice. So that's just one example for how you can take some of this information out, start doctoring it up a little bit for your own kind of drawing purposes. Okay, and I'll go back to my sandbox layer. And there you go. You can always turn this stuff on or off as you move. Okay. I did want to do one more thing, I guess, which is to show you how you can customize the gradient colors that are coming out of some of these components. So I'm going to turn this one back on, which should be giving us our, there it is. Oh, got to turn that on. Okay. And let's turn the shadows off. And I like to disable that preview for this one, because if I ever make changes to this, these shadows take a little bit of time to calculate. So, you know, you want to right-click, or yeah, you can right-click on this and just disable it. And that'll make it go gray, which means it won't calculate anything. Here I just wanted to go back for a second to this. Turn this building off. Okay, this is using that angle. That's fine. But I'm going to give this a duration because I think the results are a little bit more clear for this example. So I'm going to plug that in now. Oop. Careful. Yeah, you don't want that. Plug this into our analysis period instead. All right, so that'll give us a nice gradient of colors throughout a few hours of one day. And I want to just show one way you can customize the legend and the colors. Okay, so let's go to Ladybug again. Just put that over here. And I think it's going to be an extra. Yeah, so extra, you can see this Ladybug legend parameters here. It's going to need a lower and higher bound, a number of segments, and the custom color action here. Okay, so let's see. Also, you can see that this is going to look for legend parameters, and we can input the results of this into here to update the colors that are coming out of this component, and thereby coming out of this, out of this component there. So in fact, I'm going to put this over a little bit closer to this one so that I can work directly into it without getting confused about the output here. So I'm just going to set some custom parameters here, which will be a little more clear in terms of how many hours of the day we're talking about. In terms of the segments, let's see, I got from 1 to, okay. So I'm just going to turn this to 15, and that's going to be our bounds. The number of segments is going to be one more than this so that it's a nice even breakdown. The colors, we're going to use a gradient for this, all right? So we'll go over to Parameters tab, Input, Gradient. Wrong one. There we go, this one here. And I'm going to set a preset to this Rasta color one here. The upper boundary, you can leave L0 out. The upper boundary is going to be our number of segments, because that has to match with that, so we don't get any duplicates. And then we just need to grab a set and series and just plug that 16 into the C input there and plug that into the T into here. Okay, so that'll give us our range of colors that is relative to the number of segments and boundaries that we've given it, and then this can come direct into custom colors. The last thing is going to be legend scale that we'll play with in just a second, and I can plug this into, where is it, legend parameters. And now we've updated, so now each one of these colors is assigned, or we've now have a certain number of steps which match all of our colors, so there's no decimals, simplifying that a little bit. And we've also updated the colors to, let's say, more of our liking. And this could, of course, be customized. The legend scale could be customized as well in case you want to print it smaller. That's a bit small, obviously, so we can increase that a touch. You get the idea. We can turn off those mesh edges if you like. Take a look at this as a kind of a low res, you know, kind of block model. And you can play around with your presets if you like. This one makes no sense. Probably don't want to use that one. This one also doesn't make a lot of sense unless you reverse the upper and lower. You know, red shouldn't probably be matched up to something that's low. Red is usually something high in this world. You know, a lot of radiation, not a lot of radiation. So I'm going to use this one just to illustrate the idea. And one other thing to pay attention to, again, is that the meshes are also allowed to be output here. So our context mesh and our analysis mesh. Let's output that as a mesh into Rhino. I'll turn this off for a second, and I'll bake this into Rhino on its own layer. So let's create a new layer. Sorry, that was the wrong, the analysis mesh is the wrong mesh. That's the uncolored mesh. The sunlight hours mesh will be the colored mesh. And if we bake that onto our analysis layer, we should get the colors to come with it directly in Rhino. And we can see that there. So I can turn that off for a sec and zoom in over here. And this is a Rhino mesh, as you can see. Can move it around. And the nice thing about meshes is that they can be export with color. And this can be used in a rendering, in a drawing. You can use this for some nice screenshots, stuff like that. All right. Very good. Okay, that's it for the introduction to Ladybug. Next week we'll cover a little bit more about how we might be able to optimize using this tool. But for now, this is a kind of an introduction to some of the stuff that you might be able to make use of. Just before we click off here, just wanted to point out that there are quite a bit of online resources for this. This is a great website that comes directly from the Ladybug Tools homepage. So we can click on Ladybug, and it'll give you some ideas for what you can do with it. And then if you click the example files, it's going to take you to this website called Hydra, which is very nice actually. It loads up an actual Grasshopper file itself. Allows you to zoom in and out of it, move it around, and you can download the sample file here. All right. So this is really nice resource for you. You can do some nice ray tracing stuff, figuring out annual comforts, and so on and so forth. Different kind of shading strategies. So I would take a good look at this. See, maybe consult with your faculty. Win vertical profiles. There's quite a bit of good sample files here that you can just take direct now that you've been introduced to it, and you can see if any of this stuff will benefit your projects. Okay. Great. This is finished.